Local LLM development and tools. Tencent dropped WeDLM 8B Instruct on Hugging Face, a diffusion language model claiming 3 to 6 times faster inference than VLLM-optimized Qwen 38B on math reasoning tasks. This is significant not because diffusion-based language models are new, but because skeptics had largely written them off as fundamentally unsuited for accurate text generation. The Apache 2.0 license makes it immediately available for experimentation, and Tencent also released a 7B variant converted from Qwen 2.5 to demonstrate their architecture conversion capabilities. Community reaction ranged from cautious optimism to requests for quantized versions from the usual suspects, Unsloth and Bartowski, suggesting genuine interest in practical deployment. XLlama v3 continues its march toward universal model support, adding GLM 4.7, GLM 4.6 volts, Ministral, and Almo 3 to its roster. The single developer project led by TurboDerp has become the go-to quantization framework for users seeking VRAM efficiency without sacrificing quality. One user noted it's about the only way I can have fully offloaded GLM, highlighting the practical necessity of such tools. The community's recurring lament about Kimi linear support, a complex architecture even TurboDerp hasn't cracked yet, speaks to both the project's reputation and the genuine technical challenges remaining in this space. For those pushing language models into unconventional territory, one developer fine-tuned Llama 3.1 with a 20K token context length to generate 3D furniture mesh structures directly from text prompts. The approach extends NVIDIA's Llama mesh research but targets more complex geometry than the original 8K context implementation could handle. A demo at lm3d.space showcases generated sofas, cabinets, chairs, and tables, though it's running in testing mode due to GPU hosting costs and the rather sobering 7 to 10 minute generation time per example. The most architecturally interesting release comes from a developer who built Kale, a local voice assistant that auto-discovers N8N workflows as tools through Model Context Protocol. The stack combines Ollama, running Ministral 3.8b, LiveKit for WebRTC, Whisper for speech-to-text, and Kokoro for text-to-speech. The key feature is infinite tool expandability. Add a workflow to N8N, and Call automatically learns to use it. The system can even build its own tools on command, representing the kind of self-extending capability that makes local AI systems genuinely useful rather than merely impressive. Meanwhile, RuCode 3.37 adds native support for GLM 4.7 and Minimax M2.1, alongside experimental custom tools that let teams ship tool schemas alongside their projects. On the infrastructure side, one developer is seeking testers for an offline-first vector database designed for local AI workflows. AI security and cybersecurity applications. A cybersecurity researcher has trained and released a 24B parameter cybersecurity-focused LLM on 40,000 security examples, with Q4KM and Q6K quantized variants designed for consumer systems with 8 to 24 GB VRAM. The explicit goal is creating an uncensored model for legitimate security research, the kind of work where general-purpose LLMs, safety guardrails become obstacles rather than features. The developer is actively seeking collaborators, positioning this as a community resource rather than a commercial product. Whether such specialized models actually outperform prompting general models with security context remains an open question, but the approach of domain-specific training on curated security data has theoretical merit. The ZeroDin Sidekick browser extension represents the tooling side of AI security research, providing infrastructure specifically designed for LLM jailbreak testing and vulnerability discovery. The standout feature is automatic detection of successful jailbreak attempts. The extension analyzes LLM responses and determines whether a prompt bypassed safety guardrails. A chain mode automatically suggests follow-up prompts when initial attempts fail, creating the iterative feedback loop that professional red teaming requires. Token usage tracking helps researchers budget API costs, while one-click submission to the DIN platform enables community sharing of discovered vulnerabilities with proper categorization and severity ratings. A research paper from Ben-Gurion University explores proactive defenses against malicious LLM agents through deception techniques. The researchers demonstrated success in disrupting, detecting, and neutralizing malicious agents by cloaking assets, deploying honey tokens, and trapping agents in loops. This work is notable because it explicitly leverages LLM weaknesses as defensive advantages, a mindset that will be essential as AI-powered attacks become more prevalent. The timing is relevant given reports from vendors like Palo Alto, ranking on offensive capability leaderboards, and broader concerns from figures like Bruce Schneier about autonomous AI hacking capabilities. One particularly entertaining benchmark, Apocalypse Bench, tested 305 survival questions across 13 domains to evaluate which LLMs would kill you in a post-collapse scenario. The results are grimly instructive. Llama 3.1 8b advised heating canned beans to 180 degrees to kill botulism. Spores survive well above that temperature, while Quen 3 suggested identifying mystery garage liquids by holding a lit match near them. GPT-OSS won overall, but still recommended putting unknown chemicals in your mouth for identification. Gemma gave perfect cabbage seed-saving instructions, except for the minor detail that cabbages don't have seeds in the head. The benchmark's creator suggests a survival committee approach, different models for different domains, and keeping physical books handy. Claude AI tools and monitoring. Claude Watch, a new open-source desktop application, addresses a specific pain point for Claude Code Power users, monitoring context usage across multiple active sessions in real time. The tool displays a floating window showing context percentages for each session, with alerts at 75% and 90% thresholds to help users save work before Claude compacts conversations. Built with Go and Wales, the MIT-licensed project has pre-built binaries for macOS and Windows, with the developer actively seeking testers for Windows and Linux platforms. The tool sparked discussion about its necessity given Claude's built-in usage meters. The key distinction is workflow. Claude Watch monitors multiple background sessions simultaneously without requiring users to check each terminal individually. One commenter noted this becomes critical for users who have disabled auto-compact, a deliberate trade-off that requires more active context management. The discussion revealed that adding indicators for waiting prompts or actively working status would be straightforward given the app's existing monitoring infrastructure, suggesting future feature expansion. For developers managing multiple Claude code sessions during complex projects, this kind of meta-tooling around AI assistance may become increasingly valuable. A more ambitious project, TurboFlow Claude, provides an advanced agentic development environment supporting dev pods, Rackspace Spot instances, GitHub code spaces, and Google Cloud Shell. The system features over 600 AI agents, Claude Flow integration, Spark methodology, and automatic context loading. The v1.0.4 alpha release includes SpecKit integration for spec-driven development, 38-plus installable skills, N8N workflow building with AI assistance, and multi-model orchestration across Gemini, GPT, Grok, and Ollama. The project demonstrates how Claude is being wrapped in increasingly sophisticated scaffolding to enable complex multi-agent workflows. AI agent frameworks and universal tools. MCP Next from HKUDS represents a significant architectural advance in how AI agents interact with tools, addressing three fundamental challenges: context overload, tool quality issues, and limited capability scope. The core innovation is a paradigm shift from load everything to retrieve what's needed. Current MCP implementations suffer from loading all configured servers and tools at every execution step, creating an overwhelming action space that degrades performance and accuracy. The multi-stage tool retrieval pipeline implements progressive filtering, server selection, then tool name matching, then semantic search, then LLM ranking. Each stage narrows the candidate tool set, optimizing both precision and speed. Pre-computed embeddings enable one-time processing with instant reuse across execution steps. No redundant loading. The architecture claims constant time performance scaling from 10 to 10,000 tools with continuous improvement through persistent memory. For production deployment, built-in reliability tracking and safety controls provide the operational guardrails that prototype stage agent frameworks typically lack. The broader significance lies in what this reveals about the agent tooling landscape. The naive approach of exposing all tools simultaneously doesn't scale. As agents gain access to more capabilities, system operations, GUI automation, deep research, intelligent orchestration becomes essential. MCP&X's approach of treating tool access as a retrieval problem rather than a configuration problem may become the dominant pattern as agent frameworks mature. Section programming and development infrastructure. Andrei Karpathy's recent observation on programming's transformation captures the current moment with characteristic clarity. I've never felt this much behind as a programmer. Coming from someone who helped build GPT at OpenAI and taught deep learning to millions, this carries weight. He describes a new programmable layer of abstraction involving agents, subagents, their prompts, contexts, memory, modes, permissions, tools, plugins, skills, hooks, MCP, LSP/commands, workflows, IDE integrations, requiring mental models for fundamentally stochastic, fallible, unintelligible, and changing entities suddenly intermingled with what used to be good old-fashioned engineering. The metaphor of a powerful alien tool handed around with no manual resonates with practitioners struggling to integrate AI assistance effectively. Karpathy estimates he could be 10x more powerful if he properly assembled the capabilities that have emerged over the past year, and failure to do so feels decidedly like skill issue. This framing, productivity gains as the prize, but with no roadmap to claim them, captures both the opportunity and the anxiety pervading the profession. On the more traditional infrastructure side, Ratatouille continues its development as a Rust library for building terminal user interfaces. The project has spawned thousands of TUI applications, including oscilloscopes, peer-to-peer games, binary analysis tools, and API browsers. The emphasis on sub-millisecond rendering, zero-cost abstractions, and responsive constraint-based layouts reflects ongoing demand for high-performance terminal tooling. New no-STID compatibility enables embedded targets, expanding the library's reach beyond traditional server and desktop environments. RuVector MinCut implements the December 2025 breakthrough in deterministic exact subpolynomial updates for minimum cut algorithms. The library targets self-healing infrastructure, AI agent coordination, and safety-critical systems, applications requiring continuous structural integrity monitoring. The technical innovation enables real-time tracking of network vulnerability without full recalculation, supporting use cases from brain mapping, identifying weakening neural connections, to 5G mesh networks handling thousands of connections per second. For AI systems specifically, applications include model pruning, multi-agent communication bottleneck detection, and continual learning analysis. A philosophical treatise on logging practices argues that traditional approaches are fundamentally broken for modern distributed systems. The solution proposed is wide events, single context-rich log events containing 50+ fields per request per service. The problem: a checkout request might touch 15 services, 3 databases, 2 caches, and a message queue, yet generate 17 separate log lines with inconsistent formatting and missing context. When debugging at 2 a.m., searching for user 123 reveals 5 different formats for the same user ID with no way to correlate events. The prescription is structured logging with high cardinality fields that support proper analysis rather than string search. Security vulnerabilities and exploits. MongoBleed, CVE 2025-4847, is a newly disclosed memory leak exploit targeting MongoDB's zlib decompression handling. The technique crafts BSON documents with inflated document lengths, causing the server to read field names from leaked memory until encountering a null byte. The proof-of-concept script by Joe Desimone iterates through different document lengths and buffer sizes, extracting leaked data from error responses and scanning for sensitive patterns like passwords, secrets, keys, tokens, and AWS credentials, aka prefixes. The vulnerability enables unauthenticated remote attackers to potentially extract sensitive information from MongoDB server memory. FreeBSD's Artsold daemon suffers from CVE 2025-4558, a command injection vulnerability in DNSSL, DNS search list, domain name handling. The daemon fails to validate domain names for shell metacharacters before passing them to system calls, enabling command substitution that achieves remote code execution from an adjacent network. Affected versions span FreeBSD 13.x, 14.x, and 15.x before December 16, 2025. The attack requires Layer 2 adjacency to the target, not remotely exploitable over the internet, but dangerous in local network environments. For those seeking defense rather than exploit, CipherZero provides an offline 2E password manager with TOTP support, AES-256 GCM encryption, and OS keyring integration. The implementation uses Argon 2ID key derivation with security-conscious parameters, 5 iterations, 256 megabyte memory, 4 threads, integrates with macOS Keychain and Linux Secret Service, and supports TOTP with QR code export. The Vault architecture encrypts with a random master encryption key, deriving the actual encryption key from password plus keyring secret. Backups require a recovery phrase rather than the primary password, a design choice preventing password-only recovery attacks. A LinkedIn post traces the conceptual roots of AI's current offensive-defensive asymmetry to an unexpected source, a German teenager's 2001 high school project. JoeBot, a Counter-Strike bot with just 77 parameters compared to GPT-5's 1.7 trillion, was nearly unbeatable. The key insight: the bot's training benefited from a binary scoreboard, hit target, yes, no, providing cheap, perfect verification. This observation extends to modern AI security dynamics. OpenAI's models improved from 20% to 90% on CTF challenges in 8 months because "did you capture the flag?" is binary. Microsoft's Project Ire achieved 98% precision on malware classification using sandbox plus decompiler plus validator scaffolding. SecGemini pointed at forensic logs hit 12% precision. Attackers get free verifiers. Shell popped, credentials worked, data exfiltrated. Defenders face SIEM systems generating 10,000 false positives per 9 true alerts. The thesis: if you can't verify it, you can't automate it. The prescription isn't better AI, but better verifiers, honey tokens, replay harnesses, policy as code, attack graphs, sandboxing. Engineering oracles becomes the competitive advantage. This framing connects to broader questions about AI capability growth. A linked document references the idea that current LLM architectures are repeating 1945's biggest security flaw, presumably referring to how early computing systems were designed without security as a fundamental consideration. The parallel suggests that just as early computers required decades of retrofitted security, current LLM architectures may be similarly building in fundamental vulnerabilities that will take years to address, if they can be addressed at all without architectural changes. The verifiability gap between offense and defense may be less a temporary imbalance than a structural feature of how these systems were designed.